Hello, and welcome to the lesson on advanced trigonometry. What are we going to learn in this lesson? First, we'll understand what are reciprocals of standard trigonometric functions and what are they called. Then we'll try and understand how do we find the sine and cos values for angles which are greater than 90 degrees. And finally, we'll try and understand how do we decide upon the sign as in positive or negative of the trigonometric functions in different quadrants, if the angles are in different quadrants, right? Well, let's get started then. So let's first understand what are the different reciprocals of trigonometric ratios. The first one is cosecant. Cosecant of an angle is the reciprocal of sine of any angle. Because sine is opposite over hypotenuse, cosecant of an angle will be hypotenuse over the opposite side. For example, in this triangle, cosecant of A would be hypotenuse, which is C, over the opposite side, which is A. Similarly, cosecant of angle B would be hypotenuse, which is C, over the opposite side of angle B, which is B. Cosecant of any angle is also called cosec in short. Secant of any angle. Secant of an angle is the reciprocal of cosine of that angle. As you know, cosine of any angle is adjacent upon hypotenuse. So secant of an angle will be hypotenuse over the adjacent side. For example, in this triangle, secant of A would be C, which is the hypotenuse, divided by the adjacent side of angle B, which is B. Adjacent side of angle A, which is B. Similarly, secant of angle B would be hypotenuse, which is C, divided by adjacent side of angle B, which is A. Secant of an angle is also called sec in short. Finally, cotangent of an angle. Cotangent of an angle is the reciprocal of tangent of an angle. As you know, tangent of an angle is opposite side over the adjacent side. So cotangent of an angle will be adjacent side upon the opposite side. For example, in the same triangle, cotangent of angle A would be B over A because B is the adjacent side of angle A and A is the opposite side of angle A. Similarly, cotangent of angle B would be A over B because A is the uh, adjacent side of angle B and B is the opposite side of angle B. So at times you need to remember the reciprocal of these standard trigonometric ratios as well. Okay, cotangent of an angle in short is also called as cot. So please understand cosec, sec and cot of angles are nothing but reciprocals of sine, cos and tan of the respective angles. Well, now let us try and find out how do we get the trigonometric ratios, especially sine and cos for angles more than 90. Because if I know sine and cos, I can easily find tan. Tan is nothing but the ratio of sine of an angle and cos of an angle, right? Sine over cos is tan. So we'll try and understand how do we find the sine and cos of an angle which is more than 90 degrees. For that, I'll introduce the concept of unit circle, right? Before that, let us first understand how are angles measured. Angles are measured from positive x-axis and in anti-clockwise direction. So please remember this concept very well. When we have to measure angles in a coordinate plane, we always measure it from positive x-axis and in anti-clockwise direction. For example, in each of these four situations, you will find that the arrow head, which is in blue color, is making a 30 degrees angle with x-axis. But is the angle 30 degrees in each of the four cases? Well, you'll realize that it is not. They're all different. For example, in the first case, with respect to the positive x-axis, if I go clockwise, the angle is actually 30 degrees, right? However, in the second figure, if I start from the positive x-axis and go clockwise, as you can see, the angle would be 30 degrees short of 180, right? Because had it completed the full semicircle, it would have been 180 degrees angle. But this is 30 degrees short of that, and hence your angle will be 150 degrees. In the third situation, if I start from the positive side of x-axis and go anti-clockwise, the angle that I need to cover will be 30 degrees more than 180, because a semicircle would have been 180, but this is 30 degrees more than that, so the angle is 210 degrees. And finally, if I start from the positive x-axis and go anti-clockwise, okay, that's the angle I need to cover, which is 30 short of 360 degrees, because had I covered the full circle, it would have been 360 degrees. But this is just 30 short of that, which means the angle this time is 330 degrees. So the first thing you should understand is how do we measure angles in a coordinate plane? So it always starts from the positive x-axis and we always go anti-clockwise, right? Now let us understand this concept of unit circle, which I mentioned earlier. What's a unit circle? Well, simple. A circle with a radius 1 unit and the center being at the origin, right? That's called a unit circle. A center is at the origin and we draw a circle with radius 1 unit. So where do you think this circle will cut the uh, axis, the two axes? So on the x-axis, the circle will cut at points 1, 0 and -1, 0. And on the y-axis, the circle would cut the y-axis on 0, 1 and 0, -1, right? Now, the radius of this particular circle, as you know, is 1 unit, right? So if I rotate this by an angle theta, remember rotation is always from positive x-axis and in anti-clockwise direction. So if I rotate this by an angle theta, you will get that line, right? Now, what are the coordinates of the point where the tip of the arrow touches the circle? Okay, what would be the coordinates of that point? If I drop a perpendicular from the tip of the arrow, okay, to the x-axis, you will realize that I will end up getting a right angle triangle. Let's name the sides of this right angle triangle as x and y, correct? And hence, the coordinate of that point where the arrow cuts or touches the circle will be x comma y, right? Basically, the x coordinate of that point will be x because it is x units away from the y-axis, whereas the y coordinate of that angle will be y because that same point is y units away from the x-axis, right? Now let's use trigonometric principles to find out the values of x and y. So if you look at the triangle carefully, what is sine of theta? Sine of angle theta will be opposite, which is y, upon the hypotenuse. And remember, it's a unit circle. So hypotenuse is the radius, which is 1 unit. So sine theta will be y divided by 1. And cos theta will be adjacent, which is x. The adjacent side of theta is x divided by hypotenuse, which is 1. So as you can see carefully, because the denominators of both the fractions are 1, you will actually end up getting y as sine theta and x as cos theta. So y equals to sine theta and x equals to cos theta. So I'll replace the coordinates of that point on the circle by cos theta and sine theta respectively, x by cos theta and y by sine theta. So that brings us to a very interesting relationship that any point on this unit circle, the coordinates of the point will be, the x coordinate will be cos theta and the y coordinate will be sine theta, where theta is the angle, okay, that the point makes. Okay, if I draw the radius from the center to that point, the angle which the radius makes with the positive side of x axis, right? That's theta. The coordinates will then be cos theta and sine theta. right? Now what I'll do is I'll reflect this particular arrow, okay, across X and Y axis, right? Because they are symmetric, as in they are reflected, okay, the points will also get reflected, okay? So the point which is at the tip of the the orange colored arrow, okay, would be minus cos theta because the x coordinate would have become negative. The y coordinate is still positive, so it is still sine theta. So minus cos theta and sine theta. What about the coordinates of the point at the tip of the pink colored arrow, okay, which is in the third quadrant? Well, as you can see, it is a reflection, right? So the x and the y coordinates in terms of magnitude would remain the same, but both of them will be negative because they are in quadrant 3. Both of them will be negative. So it will be minus cos theta and minus sine theta. And finally, the tip of the red colored arrow, which is in quadrant 4, once again, magnitude wise, it will be cos theta and sine theta. But the x coordinate would still be positive. The y coordinate will become negative because it is on the lower side. So it will be cos theta and minus sine theta. Right. Now let us compare these angles, okay, with the angles that each of these are making with the positive side of x-axis. Remember, the first one, which is the orange colored arrow, is actually making an angle of 180 degrees minus theta. Remember that, right? It's 180 take away theta because had that covered a full semicircle, it would be 180 degrees, but it is theta short of that. So that is 180 degrees minus theta. And the tip of that arrow, the coordinate should be cos of 180 minus theta and sine of 180 minus theta. Remember that any point on the circle will have coordinate cos of that angle and sine of that angle, right? The angle which it makes with the positive side of x-axis. Now, if I compare both the coordinates, okay, which we derived it originally and now with the new set of coordinates, you would realize that sine theta is the same as sine 180 minus theta, as you can see. And cos theta, however, is the same as minus of 180 minus theta because they are linked by opposite sign, right? Cos 180 minus theta and minus cos theta are the same, but they're linked with opposite sign. So the relation is sine theta equals to sine of 180 minus theta, and cos theta is minus of cos of 180 minus theta, right? For example, if I want to find sine of 150, all I need to do is 150 is 30 short of 180, and hence it will be sine of 30. Similarly, okay, cos of 150 will be minus of cos of 30. Right. Let's move to the third quadrant now. Okay. In this case, the angle which it makes with the positive x-axis will be 180 plus theta. Remember, it has gone theta past 180. So the coordinates of that point will be cos 180 plus theta and sine 180 plus theta. Now, if I compare the two coordinates, the one which we derived earlier with the one which is now, you realize that sine theta will be equal to minus of sine 180 plus theta, whereas cos theta will be also equal to minus of cos 180 plus theta. As you can see, the comparison, both the coordinates have changed the sign, right? For example, if I want to find sine of 210 degrees, because 210 is 30 more than 180, it will be minus of sine theta, or that is minus of sine 30. Similarly, cos of 210 will be minus of cos 30. Finally, let's come to quadrant 4, right? The coordinate that we had originally derived was cos theta and minus sine theta. But what's the angle this time it is making with the positive x-axis? As you realize, it is 360 minus theta. Okay, because had it completed the full circle, the angle would have been 360, but it is theta short of that. So 360 minus theta. And hence the coordinates of that point would be cos of 360 minus theta and sine of 360 minus theta. If you compare, the cos has the same sign, but the sine will have opposite signs. So sine theta will be minus of sine of 360 minus theta, and cos theta will be the same as cos 360 minus theta. For example, if I want to find sine of 330, because 330 is 30 short of 360, it will be minus of sine theta, which is minus of sine 30. Similarly, cos of 330 will be the same as cos of 30, right? Now, please understand, how do the angles match up in each of the four quadrants? Okay, so if it is in this quadrant, quadrant 1, you'll take the normal angle, which is theta. If it is in quadrant 2, if the angle or the ray is in quadrant 2, then you'll always have 180 minus theta. Remember, it is theta short of 180. In the third quadrant, the angle will always be in the form 180 plus theta. And in the fourth quadrant, the angle will be in the form 360 minus theta, because it is theta short of 360, right? In the first quadrant, both sine and cos will be positive, because both coordinate and y coordinate of any point in the first quadrant is positive. So for sine theta and cos theta, both sine and cos values will be positive. In case of angles in the second quadrant, which is between 90 and 180, if the angle lies between 90 and 180, then the sine will be positive, but the cos will be negative, because, right, because the x coordinate has become negative, that's cos. The y coordinate is still positive. What about the third quadrant? Okay, in the third quadrant, the angles will be between 180 and 270, correct? 180 and 270. For those angles, both sine and cos will be negative, because in the third quadrant, both x coordinate and y coordinate are negative. So sine and cos both will be negative. Whereas in the fourth quadrant, these are angles between 270 and 360, right? In the fourth quadrant, the sine will be negative because the y coordinate is negative. The x coordinate is positive, right? In the fourth quadrant. So cos will be positive, whereas sine is negative. It is extremely important to understand and realize, okay, what would be the sign of each of these angles in different coordinates or quadrants rather. Right. Finally, we'll deduce the same relationship that we deduced earlier using unit circle, but this time we'll use the sine curve and the cos curve, okay, to understand that. So as you know, the sine curve is a wavy curve. It starts from 0, okay, and reaches 1 for 90 degrees and comes back to 0 at 180. And then it goes on the negative side, becomes -1 at 270 and comes back to 0 at 360. On the other hand, the cosine curve starts at 1 at 0 degrees and reaches 0 at 90 degrees. Then it goes on to -1 for 180 degrees, comes back to 0 at 270, and then finally it moves to +1 at 360. Now, if I demarcate this angle theta from each of these edges, okay, from 180 from 180, both sides I demarcate theta. From 0, I mark theta, and from 360 also I mark theta, and join these. Okay, you will realize that sine of theta and sine of 180 minus theta have the same signs, right? They are both positive. Whereas on the opposite side, okay, sine of 180 plus theta and 360 minus theta. Okay, as you can see, they are on the negative side. They will have the same sign, but they will be negative of the earlier two signs, right? Minus sine 180 plus theta and minus sine 360 minus theta. Let's look at the relationship for cos. Okay, so let's demarcate the same angles theta from each of these. Okay, so from 0, from 180 on either sides, and from 360. And if I now join these angles, you realize that cos theta and cos 360 minus theta, the two extremes, okay, will be both positive, as you can see, because they are above x-axis. Whereas the middle two values, which is cos 180 minus theta and cos 180 plus theta, will both be negative, right? Because they are below the x-axis. So all of them will have the same magnitude, but the important thing is to deal with the sign. Please remember this, right? Well, that's the end of advanced trigonometry lesson. I hope you understood the concepts that were taught in this lesson, right? The three things that we learned. First, we understood the reciprocals of the standard trigonometric functions, sine, cos, and tan. The reciprocals are cosec, sec, and cot, right? Then we understood how do we find uh, the trigonometric functions, especially sine and cos for angles which are more than 90 degrees. Okay, and we learned that using the concept of unit circles, remember? And finally, we understood what would be the sign, okay, which is positive or negative of different trigonometric function for angles which are in different quadrants, right? I hope you understood the concept that were taught in this lesson. Thanks a lot.